So normally we harvest corn and we really care about a clean, healthy ear with a lot of seed, right? But there are certain types of fungus that can grow on the surface of that corn ear and into the corn ear. And the one I work with is called Fusarium graminearum. It is a bright pink, so it's kind of like a Barbie fungus. It colonizes the ear, and what it also does is it produces toxins that make us sick when we eat it. So what I'm trying to do is understanding the genetics that underlie why some plants are resistant and some plants are susceptible, and to better understand what's going on under the hood, or like why is the plant that's more resistant, what is it doing to mitigate that fungus from colonizing the ear, and ultimately to prevent the mycotoxin accumulation. Yeah, so what we do is, and to start looking at the disease severities, we need to have disease pressure. So we need to have enough disease on every ear to understand which plants are resistant and which plants are susceptible. And so the best way to do that is to inoculate the plants. And so what I do is I grow the fungus in the lab, and then I harvest all of the spores off of that plate. I filter it and concentrate it to a certain level. So I do about 100,000 spores per milliliter. And I put that in a backpack sprayer and take that into the field, and I'm able to inject 1 milliliter at a time into every ear that I need to inject. And that fungus then, it delivers the fungus directly to the ear. So then it's able to grow on the surface of the ear and produce its mycotoxins. So then we can take those samples and do the analysis and start looking at how much disease is there, how much mycotoxin is there, and really get at the genetics later on down the road. So what we've found so far is that resistance to disease severity and resistance to toxins are very different. They're controlled by, we think, different mechanisms. There is a little bit of overlap, and so what we've started to do is work into some of the chemistry of what the corn is doing on a chemical level to start prevent that, because we're trying to understand what's like this avenue to limit the mycotoxin accumulation. So our collaborators are taking our inoculated samples and analyzing them for the biochemicals that are present in the sample. We're also seeing that some weather factors are important and play a role in how much disease or how much toxin is present too. So this fungus produces mycotoxins, and there is evidence that shows that you can have high levels of mycotoxin in your grain on the ear from the field without a lot of visible fungal disease present. And so that can affect down the line if a grower is selling their grain, how much they get for it, or if it's rejected. In the US though, the FDA regulates mycotoxin levels in final products. So in the US, we are at very low risk because they don't put things on the shelves that aren't within their limits. And it's very stringent. So for human consumption, it's 1 part per million is the maximum level ever allowed in a product used for human consumption. US grain quality is very high quality at the end of the day. It's very controlled and regulated, so there's not really a risk for the end consumer.